Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Patrice Roulet Fontani. I hope I've said his name right. He is the co-founder and vice president of technology at Immervision, a company called Immervision, as in immersive vision. It's a specialist developer of highly advanced and sophisticated cameras, the ones that you might find in the latest smartphones and robots.
First, thank you for this opportunity. Nice to meet you. So my name is Patrice Roulet Fontani. I'm the VP Technology and co-founder at Immervision. Immervision is a company focusing on providing the eyes of machine, designing multiple types of cameras. We started this company 20 years ago, and we were engineers looking for the perfect camera to do what we had to do. And we did not find those cameras, so we decided to build and help company to build their own cameras. So we are a team of image processing engineers, camera system engineers, but also lens designer. And that's what is unique at Immervision is we cover the complete pipeline of the vision system, starting from designing the lens, designing the camera, and also doing the image processing algorithm going inside the camera to create different vision systems.
Okay, thank you very much for that. I'm going to ask you about your company. And normally I would go to the website at this point, your company website at this point. But I'm very impressed by your background. You mentioned that it's a lab. Tell us a bit about that. The lighting is great as well. Then I'll go on to the website and we can talk about the company.
Okay, so this is what I have in the background is one of our lab and in Quebec, and basically we use this lab to characterize and specify vision system. So if you remember, we do cameras and vision system, and we design custom lenses and custom camera for different industries. And we use all the equipment behind me to characterize the performance of those vision system, making sure that the pixel we deliver to our customer are the right one to do their application. Talking about robotics, for example, we know that pixel quality is key for computer vision. So using those tools, we are able to making sure that the camera achieve the right performance to serve the application purpose.
Right, and I'm very tempted to ask you another question with that in the background. Just one question before I go to the website, a general question, because I'm not an expert in these things. What differentiates industrial standard cameras and perhaps consumer standard cameras, the things that, for example, people find in our smartphones and digital cameras probably don't exist anymore. You know, there was a time not too long ago we used to have pocket digital cameras, and they were growing in the number of megapixels from 1 to 10. I think they went over a period of 2 to 3 years and things like that. I don't know what for example, my iPhone, what the resolution on that is, but give people like me a brief explanation of what the differences are between industrial standard cameras that you supply and perhaps the consumer ones that I've just mentioned.
So basically, just to rephrase a little bit and what I had said in the beginning. So basically, we design custom cameras for different industries. So you mentioned industrial cameras. We do such type of cameras. You mentioned also smartphone cameras. We do as well smartphone cameras. So we covered a wide spectrum of camera design from industrials, consumer, smartphone, automotive, but also camera for broadcast like a TV or sports events, and also camera for space exploration. Basically, the common point in our design and what is our expertise is we design those cameras to capture wide-angle field of view. So we are experts in designing wide-angle cameras with combined with image processing. So now to come back to your question about the resolution and the number of pixels, we have seen in this 20 years journey of designing multiple type of cameras for different industry an increase in pixel resolution. So the sensors are becoming bigger and bigger with higher and higher resolution to capture more information. And what we have seen as well as a designer of such a system, the requirements for the lens design and the camera design are becoming more and more important. So the quality of those components has to be perfect to match this evolution in sensor miniaturization and increase in resolution. So that's what, through those 20 years, we improve our techniques to design wide-angle cameras to match exactly the quality imposed by this evolution in technology on the sensor itself. Miniaturization is one of the key achievement that we reach over those 20 years. So we start with kind of big super wide angle camera for industrial, and we still do it, but we miniaturize the technology using freeform lenses to reach like the size required to embed the camera inside the smartphone. And also, talking about space exploration or automotive, the environment is very key. Like the camera has to be reliable and sustain hard condition. So that's also an improvement in terms of technology we have done in those past 20 years to increase the reliability and all the camera perform in very challenging conditions.
Yeah, and just to, again, as I say, I'm not an expert, so I'm probably asking very basic questions. Just to clarify, these are vision cameras in the sense that the way the human eye sees, they're not LiDAR cameras or any sort of that kind of thing, are they? Are they vision cameras, natural vision cameras, if you like? Right.
That's a great question. It's a great analogy because our specificity is to design cameras with wide field of view. So that's very much where we are good at. And when we start designing those cameras, we were inspired by human vision. So basically, if you look at the human, we can see wide, but also we have an area in our field of view for human is the center, and where we can see in super high resolution. So we were inspired by this specificity of seeing wide, plus with certain areas in high resolution to read text or see details. So that's the way we design our optical system, like designing super wide angle camera, plus with an area of focus where we can see in higher resolution. For example, endoscopic or robotic application, we prioritize the center of the field of view, capturing wide with high resolution in the center. But for other applications, like for example, smartphone or action cameras, we focus more on the side of the image because they want to maintain a very high quality toward the full field of view. For security, it's the surrounding part of the camera which is in higher resolution. So we have this specificity to design wide field of view plus higher resolution in certain area.
Right. Very interesting indeed. I can't help going back to the space thing because, yeah, I'm like a lot of people very interested in space, and I love those pictures that NASA sometimes show that they've got from Hubble telescope or some other thing, maybe the rover on Mars or something. But as I don't know if this is true, but as far as I understand it, they use a completely different kind of capturing technique, radio waves or something like that. And when they first show them the pictures, they're like very grainy black and white things, and then they do some put it through some process, and then the colors and things like that are added, and it looks spectacular by the time it's finished. But it starts off very different, if you like, very basic. Could you? I don't know how much you can. It's probably it's outside of your area of expertise, maybe, but you do have you know more than me. If you could explain something about it, I'd appreciate it.
So basically, for space exploration, so there is different type of cameras or sensors. So you can think about the sensor that are on Earth inside the telescope, for example. So capturing different wavelengths from different part or object in space. So that's one field. We did some work in the past for those type of equipment, and we have designers very experienced in this area. So that's one thing. The other thing in space exploration, there is a trend now to have to send camera to space to see to capture, I would say, what's happening on let's say. We have seen videos from the space station. We have seen picture from Mars rover, for example, and those equipment also require cameras and RGB cameras, like the same type of camera we have in our daily life device, but repurposed to sustain the hard condition that's happening in space, so temperature, radiations, and all other vibration that's due to the launch. So for this, it's very ruggedized camera designed for this purpose. So that's one thing. So we call that RGB cameras. But there is also other type of sensors. You mentioned earlier about the LiDAR. So I'm used to say that LiDAR is also a camera because there is optics. There is a light that is the laser that's emitting the light and the sensor that collecting this light. So for me, it's also a cameras. And for this, our technology in terms of designing super wide angle type of cameras is also applicable to LiDAR. So LiDAR is different camera, but similar in some extent.
Yeah, I'm very interested in cameras as part of robotics because you'd know better than me. But as far as I understand it, I mean, a lot of them are increasingly using vision to, become more and more autonomous, more and more self-learning. They look at their surrounding environment or the object that they're manipulating, and they can do what's necessary, the task in hand, without as much programming or as much technical support as before. I don't know if that's correct, but what have been the steps forward that cameras have enabled, and what do you think the steps going forward from now will be? How will cameras evolve to become more helpful to robots and machines, perhaps autonomous cars as well? What kind of innovations have you seen and do you see going forward?
Okay. Yeah, so basically, so since the invention of the CCD and the CMOS, so the sensor to digitalize the light, so the camera was designed very much for human vision. So we designed cameras first for security, so to capture to monitor the environment. Then after that, the smartphone and the action cam raised. So everyone now has multiple cameras in their hands all day long. And it was very much designed for human vision to make sure that the performance of the camera please the human eyes. Then since, let's say, 2010, 2012, the rise of computer vision and AI came. And we had to rethink the way we design cameras and bring innovation, not to please human only, but to please human plus machine learning and computer vision. So the computer vision algorithm and the machine learning algorithm are not sensitive to the same, I would say, performance or sharpness than the human vision. So a lot of innovation has to be was done and has to be done to please the computer vision algorithm for robotics, for example, and that's where we are in very deeply. So we design camera that making sure that we deliver the good pixels for the application. So if the application is robotic, computer vision, or machine learning, we make sure that we design the camera that will deliver the right information for the machine learning or computer vision algorithm to take the right decision.
Right. One last question before I move on to the website, and then we can maybe go through some pages of the website and you can explain them. But 3D vision, how do cameras, how are they made to perceive depth? I know that I haven't got one, but the new iPhone has 3 cameras, I think, and it's probably because of the 3D requirements of augmented reality and so on and so forth. I don't know, but how do you use machine learning perhaps to get the computer or the camera to perceive depth?
So let's start by again with the human analogy. So basically, as human, we have 2 eyes. And using those 2 eyes, we are able to understand depth. So basically, there is a difference in distance with those 2 eyes, and those 2 eyes are able, with the difference in distance, to understand that my keyboard is in front of my computer screen, which is in front of the wall, etc. And all those keyboard and screen are on my desk. So with these 2 eyes, we can understand that. So that's why, for example, you mentioned the example of the smartphone. With multiple cameras, they can compute the depth considering like basic triangulation of those 2 cameras. That's what some robotics application use this as well. We have a program we call Joyce, where this humanoid robot, we bring 2 eyes in front to understand the depth. Plus, so now after that, there is, as a human, if I hide one of my eyes, in some extent, my brain was trained to understand the depth and continue to understand the depth. So even if I close one eye, I can still see that the keyboard is on top of the desk and in front of my computer screen. And there is also some algorithm in machine learning that allow to train neural network to even with one single cameras, we can still understand the depth. So in certain conditions. So there is those 2 ways using traditional camera to capture the depth. Now there is an additional way. You have made a reference on the smartphone as well, that they start to integrate what we call LiDAR time of flight camera. So basically, this is a new way to also capture the depth using the time of when the light go out of the camera, hit an object, and come back. So this time, in a sense, give the information of depth, because far in the object, more time the light travel the space to hit the object and return. So this is another way to capture the depth. And I was mentioning the humanoid robot we are working on right now, which is Joyce. And this robot our goal is to provide those different techniques to capture the surroundings. So 2 eyes in front to capture the conventional 3D with 2 cameras, 2 traditional cameras, super wide angle. 1 camera on the back, also super wide angle to capture the surrounding. of the robot, and also using those 3D LiDAR ToF camera to capture the depth on a different way using the time, what we call the time of light. So the time the light takes to go outside the camera, hit an object and come back in. So this is also give the information of the depth.
Thank you very much for explaining that. I've heard the phrase time of flight many times, but I didn't actually know what it meant. So I really appreciate that. Yeah, I've always been curious. I've been curious about robotics. I don't know when it changed or started changing, but I've seen a few years ago, I used to see cameras, or rather robots with single cameras. And when the two camera sort of systems came out, it became, you know, it occurred to me that a single camera doesn't perceive depth in the human way that I can understand. You know, LiDAR and other things notwithstanding, I understand how humans perceive depth. So it just made sense. I'm curious why they used to use single cameras in the first place. And maybe it was the lack of or limitations in computing at the time and machine learning and things like that, which leads me on to asking you about development in your field when you're developing new innovations and things like that. A lot of it is probably about computer programming now, isn't it? Because you have to make several cameras work together. I mean, that must be quite a technical challenge in terms of software. The different types of sensors and cameras that you might use in order to make one single system see and perceive better. So what is it? Is it the hardware kind of staying approximately the same, and software is like the big concern at the moment? Software development. How is development approached at the moment towards innovation and new products?
So I would say that there is 3 pillars that we are working on very intensively. So the first one you mentioned, that is the compute and the image processing. So wide angle, sensor fusion, and image processing. So image processing is one. The second is so having more and more using the compute power to do more and more advanced processing. The second is the sensor fusion. So to capture the full surrounding, and we cannot rely on only one single camera. So there is more and more sensors that are required to capture the world. So we are working on sensor fusion. So adding multiple cameras together, stitching them together to capture the full surrounding, plus combining this information with other sensors like inertial motion unit, GPS, and others. And the last pillar is the wide angle optics. So we design advanced optical system to make sure that we deliver good pixels for the image processing. So to summarize, 3 main topics we are working on. So wide angle optics to capture the high quality pixels. The sensor fusion, combining multiple cameras and sensors together to aggregate all the information of the surrounding. And the third is image processing, leveraging the computing power of the modern processors to understand the world and capture the world and digitalize the world, I would say.
Yeah, you've explained very well. Sorry, I sprung that video on you, but it was tempting to press the video play button. But it summarizes what you've said as well, and your website also does that. We'll play the video again in a minute, and maybe you can talk us through it. But this has caught my eye as well. What's this then? The Joyce, world's first humanoid robot developed by the computer vision community. It's not one of your machines, is it? Is it some other?
So basically, Joyce is a program launched by Immervision. What we have seen missing in the robotic industry is what we call the visual cortex. So basically, if you browse the internet, you see a lot of progress in humanoid robots, jumping, flying, doing some parkour, for example. But those robots, even if they behave super well in terms of physically interacting with the world, they need eyes and they need a visual cortex to understand the world. So that's what we have seen missing today, and we design the visual cortex for the humanoid robots. So by saying design is we are bringing all the different sensors, so 2 eyes in the front, 1 eye in the back, 3D ToF cameras with processing powers to process all those sensor data and aggregate them. And so that's our contribution as Immervision, to create this type of visual cortex for humanoid, and we create this JOICE program to do it. And when we say developed by the computer vision community, is we are welcoming the computer vision community to work with us to leverage all those sensors to develop innovative applications. Those innovative applications can be understand the human emotion for healthcare, for example. That can be also location and mapping, so enable JOICE to behave in his environment and locate his environment for autonomous. For example, that could be from helping car to drive better up to the vacuum cleaner in your house that's doing better his job because he understands better the different furnitures inside your house. So there is tons and tons of computer vision and machine perception application that JOICE will enable. The first step is so we work on this visual cortex to enable the humanoid robots to see, and we welcome the computer vision community to join us through challenges and different type of programs.
Very fascinating, absolutely fascinating. It's an area of robotics that Hollywood and films in general, they tend to focus much more on, humanoid robots. It's been happening for many, many decades now, humanoid robots taking over the world, or usually presented as baddies. Sometimes obviously they're presented as helpers and partners for like in Star Trek, you got Data, the robot, and other films as well. But in the real world, humanoid robots haven't really found a commercial application. They tend to be in universities and they research. It's a great field, and I hope that they progress quite well. And the other thing, the observation I'd make is that a lot of the concentration has been on language development, helping the robot or teaching the robot how to communicate using verbal, sounds and, words and things like that. So this is different in a way because vision hasn't been the prioritized, if you like. And that's probably because the ones that I'm thinking of, the humanoid robots that I'm thinking of, the Japanese guy, the famous Japanese guy, I've forgotten his name now, Ikigawa or Igakawa or something. All of them are actually more concentrating on developing language skills. The vision would only really be useful if you're thinking, or if you want the robot to move around or manipulate objects and things like that. And although there are probably 1 or 2 humanoid robots like that, that do move around, the Boston Dynamics humanoid robots, which don't look human at all, but they are, approximating human anatomy. But they're very good at moving around. They've got very good balance. They stay on their feet. They can jump over objects. I mean, that is fascinating. I don't know how they do it. They must use some sort of cameras, right? Or is it some other sensing device, you think, that they use?
I think there is two different fields in robotics in general, but in humanoid robots. So there is some companies or research centers that are focusing more on what I call the acting. So basically on all the motors and making the robot that stay in balance in different conditions, and mimicking the human behavior when you say the dancing or escalating or jumping. So that's one field, and it's very focusing on motors design, assembly, programmation of all those motors, and using some sensor just to balance those different, to make sure that the robot maintain its balance through different challenging environment. So that's one area. The other area is the computer vision. So there is a lot of research and developments in computer vision, aggregating vision sensor and motion sensor to locate to understand the surrounding world. I haven't seen yet something that combines those two in a single humanoid device, like the latest advancement in vision sensor and also in we can say robotic body. So I haven't seen that yet. Why we create Joyce, and to do another analogy about what you said about now the humanoid robot did not find yet their commercial application, what I believe they will find in the near futures, but they did not find yet the commercial application. So why we develop Joyce is we see that as like, if I do another analogy, is like what the Formula One did for car in the 50s and 60s. So our ambition is to use Joyce to develop machine perception technology that then will find their way to day-to-day application. So let me pick an example. So if we use Joyce to improve the way that Joyce perceives the environment indoor in the regular home, for example, this algorithm and this set of sensors can directly go from Joyce to a vacuum cleaner to improve the two-day vacuum cleaner. Or if we use Joyce to understand the human emotion or human body language, it can go directly from, like I would say, the humanoid robot Joyce through a device that is placed at the entrance of in a waiting room in an hospital, for example, to understand that all the people are feeling and take care of the different people according to this. So there is, our ambition is to use Joyce to develop advanced technology and then bring those technology from the, I would say, state-of-the-art advanced humanoid robot to day-to-day application in machine perception.
Yeah, it's probably the aim of many people and companies to produce a humanoid robot that has commercial applications at an affordable price. Obviously, I mean, at the moment, they'd probably be prohibitively expensive because of the rarity of their availability. Mass production, and is many years away. But I don't think. My own view is that I don't think it's series production is too far away. I mean, you mentioned using humanoid robots in reception areas. That's something I forgot. They do use them especially in Japan, in shops and hotel receptions and this, that, and the other. And it's not necessarily just a gimmick, just a marketing ploy. It could actually replace human beings, human workers in simple tasks such as greetings and explanations of directions and things like that. And I don't actually think it's too far away before humanoid robots are given or taught to do the different kinds of applications. And maybe then they will take over from certain types of robots. I mean, one of the biggest markets at the moment for robots is the warehouse robots, where they're the little platforms that have wheels, and they go around the warehouse and pick up shelf units and bring them to the human picker. Now the human picker is the only job or task that a robot can't do, because it's quite complex. It requires a huge amount of visual perception, differentiating between different products, and then picking them up and putting them into a different box to create a customer order. That's quite a complex task for a robot to do. And at the moment, it's a human that does it. Maybe a humanoid robot, or at least one with good vision, or adequate vision, and hand-like end effectors can do that job. So, yeah, I think it's not too far away. Maybe the Hollywood version of robots, which are almost exactly the same as humans, is a few decades away. But certainly humanoid robots for certain types of applications, I don't think they're very far away at all. And cameras, I would imagine, are the key innovation. The idea of teaching them language is probably a lot more challenging, because you got so many humans speaking so many different languages, so many accents, so many different types of individualized ways of speaking. It's too much for a robot, I think. The natural language, they call it natural language processing, I think. Yeah. So that, I think it's I wouldn't say it's a blind alley or waste of time. It's a very, very challenging problem to solve. The idea of vision combined with manipulation using perhaps more human-like end effectors, arms and hands, that's something I think to a limited degree could actually become commercial. It'd be very, very interesting to watch developments. And I didn't know about this Joyce project of yours, so it'd be I'd like to update our audience about it from time to time. So tell us about the other aspects of your business and company. I mean, I saw in the video that let's have a look at this video again. I was going to ask you about customers and things like that. I saw some Motorola, I think, was one of the companies I saw in this. But what kind of markets and companies are you dealing with at the moment?
So basically, one of the, you mentioned Motorola, but one of the market of wide-angle technology is the smartphone/action cameras, where we design advanced camera for those products. So, for example, you might be aware of now the smartphone accumulates multiple cameras on the back. One of those is super wide angle or wide angle. And this camera, the aim of this camera is to capture the wide field of view. So basically, we are designing such cameras for smartphone application at different resolution and miniaturizing the size of those cameras. So that's one application of our technology, and we also provide the image processing associated to this. So super wide angle camera need dedicated image processing to run inside the camera to please the human. So we provide the camera design, the super wide angle camera, plus the image processing for smartphone and action cameras. That's one application of the technology. The other application is the automotive. So also wide angle camera are required in the automotive to capture either the surrounding of the car or also inside the cabin to monitor the the behavior of the driver and the passenger. So for this, also for this industry in mobility and transportation, we design what we call vision systems. So the combination of the lens design, the camera design, and the image processing together to deliver the good pixels for either vehicle perception or other tasks in transportation. The other industry is the security. So security to providing vision system for, I would say, monitor retails, shop or bank.
Sorry to interrupt. That's you, isn't it? That's it. Okay, great. That's I didn't know where I'd find you, but yeah, there you are. This is the automotive section of your website, you were saying. And it's very interesting that the image that I clicked on was, I think, a neuro autonomous vehicle, a company called, maybe I'm wrong, but it looks like an autonomous vehicle produced by a company called Neuro. And I think the application for that vehicle is that it's an autonomous grocery delivery or grocery store, mobile grocery store, or driverless and all that. And that's something that, you know, it's another huge growth market. So if you are supplying cameras to those kind of vehicles, then I think you're onto a winner there. Yeah, sorry, go on. I didn't mean to interrupt.
Yeah. So basically, yeah, so transportation and mobility is a big focus for us. And the last one is security. So we, for example, we design the eyes of consumer drones. So the flying drones need cameras to locate themselves in the environment in different type of condition. So today, the consumer drones behave very well in what we can say bright light conditions. So going outside under the sun shining, that's perfect condition. When you go inside, what we call indoor, or also at different light condition, for example, at night or at the sunset or at the sunrise, there is some challenge for those flying drones to perceive the environment because the camera are not designed to perform in low light, what we call low light. So our contribution here is to design the new eyes for those flying drones, consumer flying drones, to enable them to behave in different type of condition. Could be outside at sunshine, but more inside at low light or at the sunset, at the sunrise, at night. So that's where we bring innovation. So designing new generation of eyes.
Yeah, it's a very interesting area to be in, and you know, you seem to be innovating a lot in a lot of different fields. So yeah, I don't know how much time. I think I've overrun the time, but I don't know if I've missed any questions. Is there anything that you'd like to add that I didn't ask about?
Maybe I would just summarize saying that we are designing advanced vision system inspired by human eyes since 20 years. We applied to those vision systems, those innovation to different industries, from security, from high-end application like space exploration and TV broadcast, going down to super miniaturized application like smartphones. Now we see the big change and rise of computer vision and machine perception, and that's a trend that we follow very actively. And we create this program JOICE, the humanoid robot, to innovate on machine perceptions. First with Immervision, creating this visual cortex for robotics, plus welcoming the computer vision community to joining us, to innovate with us and solve the robotics and machine perception problem of today and tomorrow.
Yeah, it's a great problem great challenge to set yourself. I think it's a great thing that you're doing. All right, well, it's been a fascinating time talking to you. I'll stay in touch and hopefully get some more information about Joyce in particular and the advancements or innovations that come out of that at some point in the future. Fabrice, thank you very much for your time and your insights.
That's my pleasure, and thank you very much to giving me this opportunity to talk to you. And yes, so we'll be more than happy to share more progress and news with you on a regular basis.
Okay, thank you very much. Have a good day.
You too. Bye-bye.
Bye-bye.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.